Welcome to ClickMyProject.com. This is our project title, Efficient Motif Discovery for Large Scale Time Series in Healthcare. And this is a project abstract. Analyzing time series data can reveal the temporal behavior of the underlying mechanism producing the data. Time series motifs, which are similar subsequences or frequently occurring patterns, have significant meaning for researchers, especially in medical domain. With the fast growth of time series data, traditional methods for motif discovery are inefficient and not applicable to large-scale data. This work proposed an efficient motif discovery method for large-scale time series MT-lags. By computing standard motifs, MT-lags eliminates a majority of redundant computation in the related odds and reuses existing information to the maximum. All the motif types and subsequences are generated for subsequent analysis and classification. Our system is implemented on a Hadoop platform and deployed in a hospital for clinical electrocardiography classification. The experiment on the real-world healthcare data shows that MT-lags outperform the state-of-art method even in large time series. This is our data flow diagram of our project. It's a clear flow. And first initialize the time series. Time series came from the cardiological ECG monitor results, and the images will be in the time series, initial time series, and it will be loaded into the segmentation initialization and discretization model. This model performs the sequence symbol. It will be the series time series images will be converted into the subsequences of symbol. The symbols will be converted into some symbols like what are all the values that get in the high pressure or low pressure. If it is some certain value will be produced a certain symbol. Then the sequence is then converted into the sequence symbol. The model will be completed. Then it will be sent to the segmentation compression model. It will the compression model. It compresses the higher value. The more and more values will be generated when we converted into sequences initialization sequence symbols, and will be compressed the whole data. Some data limited into the compressed into the some subsequences symbols, and subsequences symbols may be in the form of alphabets or any symbols, anything like. Then the compression model set to the standard motif computation model. The motif computation model came to the under system. It will be generated and then it will be in the standard motif. The motif is nothing but a computation of finding out the symbol and whatever the values it will be getted from the standard motif. It will be sent to the final motif discovery model. The final motif discovery model they find out the values which is find from the certain machine for a single result, and the single result sent to the what is the motif discovery. It will discovery models will what is the actual result of the particular given time series data, and then found the final results. The final results are nothing but a final results of the motif discovery of the certain machine, the certain ECG machine, certain person machine, certain person's results, and it will be how they are, if they are the critical condition or normal condition or moderate condition will be generated to, it will be find out the final results as this project will be given the final results and it will be stored in the Hadoop. Let's start our project demo and let's run the home page and right click on the home.java and select run file. The home page is running now the more efficient motive discovery for large scale time series in healthcare, and click here to enter into the system. Now we are entered into the system and select the nodes of data which is gathered from the ECG monitor, and it will be processed to the data input data, and select all data sets which is in the form of text file, and we selected the 14 data sets and combine all the data into the one file, and it will be segmentation will be converted into the symbols, and it will be converted and load the data into the Hadoop and view the data viewed successfully. Then next store the data into Hadoop. It takes several seconds to store the data, combine the data into the Hadoop OS using its IP. The file stored successfully. The combined data will be stored in the Hadoop OS and predict the data. Predict the data in the sense we will predict the every node for if it is critical or what are the situations will be find the prediction results. That means the patient's status. Predict the patient status. And the node 1 is normal and the node 3 is critical, normal, and some status situations are generated based on their prediction results, and store these results into the Hadoop. This will be stored in the Hadoop OS, and then click here to the next and find the precision. The precision formula is the number of nodes divided by the sum of all the nodes, and find the precision, and the precision will be in the 4.0, and find recall. Recall is the number of all m nodes and correct motifs. Find the of all correct motifs. Find it. It will be the result 6.0, and find F measures. F measures formula is that 2 into precision into recall divided by precision, sum of precision plus the sum of precision and recall, and find F measure. F measure is 4.8. We find out the results for this motive discovery for healthcare, and close the program. Thanks to listeners.